recording. It won't be breaching a network, because that's not what this class is teaching you anyway. It'll be, and I don't remember, I haven't looked at it since last year on it, but it's where you're going in and using the tools again to determine what has occurred, because what you're learning in this class is not learning how to attack these networks. You're learning how to figure out where they've been attacked and how to respond to the attacks. So it's not doing attacks in this class. That this is, remember, cyber center operations. So you're working as an analyst figuring out what in the world happened and dealing with that. And it'll be what you're going to do, it'll be right along with what you've done all semester. And actually, it may be already sitting out there in Blackboard for you. If you look on down at final week, I think it's posted in there. And so you can actually go ahead and look at what the final lab is. It should be sitting there. So like in this class, we would have the final lab out there, except this is a new class. And I haven't finished setting up the class yet. But when I get on down to there, and I haven't had a chance to work any more on it since the semester started, I will get it out there. I know for this class, for your final lab, for one thing, you will be doing the cabling of making the 3 patch cables, of having put the plugs on them. Which is what you're going to do for a midterm lab also, except when you do it at the final, it's without assistance. So if you get any help, me, students, the internet, whatever, that will cost you points, but you'll have already built those. And there's probably a second part. I've got to look and see what Cisco's wanting done now. I think with this new curriculum, they're also going to want you to cable some devices together and set up some configs. But I have not looked at what they've got out there for the final lab in this class, but it would be just along with what you've done in the class anyway. Midterm, I've just got it defined as midterm. It's just another, it counts as just another lab for you. So all along you've got your chapter tests to be doing. Actually, they're not chapter in this course. They're groups of modules. And then at the final, you do have 2 finals to do then. You got a final lab, which is 10% of your grade, and you got a final exam. You'll see me referring to it as a written final. It's not actually written. You're going to do it online. It's the same as your chapter or module test, except those are about 25 questions each, and the final will be about 50 questions. Covering the same material and coming from the same type test questions. So, and there should be a practice final out there for you also, in both classes. I know it's out there at NetAcad in the cyber class. I think it's activated. I think I've activated the practice final. In this class, I think there is one for this class. And if there's not, there should be before we get down there towards the end. And if it is out there, I should have activated it already, but I don't know. I'll have to double check that one. And if you would see it in assignments, and if it's not activated, you can notify me. It'll be study on your own, because in both cases, they're just covering what we've already covered all through the course. So there's really not any need for review. You can go back and look at your test and see stuff on those. Now, you may have to do it in person. That I haven't made a final decision on. The syllabus says you will do them both in person. The final lab, the lab final in both classes will have to be done on campus. That's a Cisco requirement. So you will have to come in to do the lab final. For both of them, it's doing stuff. And I don't remember exactly on the other one if you're going to have to physically wire some devices together or what. In this class, you probably will have to physically wire, cable some devices together. When you get on to the next Cisco classes, you'll have to do that for me, and you'll do your configs normally on Packet Tracer. But we'll see as we go on along the way. All right. Now, I want to get into the number systems, which is what this chapter's on, and let's talk about those for a little bit, because this is an important module. I'm going to give it to you a little bit more information than I'm quite sure the book gives it to you, although I have not read their stuff there. And my approach may well be different than their approach. Whichever approach works for you, use it. Okay. First off, I think I've got some videos out there that I recorded in the past about number systems. You can watch those also. If not, I think I do have some, and I'll get them posted in there. There is a handout out there. It should be in there. Let me look and see. There should be a handout in this module. So I guess we're module 4. Or we module 5 this week. We're module 5. So there's lectures by me out there on the number systems where I've got recordings from in the past. There's also a decimal and binary numbers book by me that's posted out there too, which actually is part of what I'm going to tell you right now. I will also be recording the lecture I give this week, probably going to be on 2 days, in each of the 2 classes. I'll try to get those posted real quick. I got chapter, just for y'all's information, chapter 3 lecture, which I know y'all already done the test, most of you. There's a few people behind. I've got that posted out there in a new link that I just added last night called Video Recordings. That's where your recordings of Collaborate and my live session recordings are going to appear. There's one in there right now, and that's just chapter 3. Those are actually sitting on YouTube. And so I'm having to upload these things to YouTube and then turn around and put the entry in here. And that takes a while. Uploading to YouTube for the one I uploaded last night, which was like 37 minutes, I think. No, it's about an hour and a half one. It took somewhere around 40 minutes to upload it to YouTube, and I had to download it obviously from Blackboard first. So I'll be adding some more stuff in those, and I'll be trying to get all of the Collaborate sessions and all my live lectures. So last week's chapter 4 should appear in there, and then after I do chapter 5 tomorrow and Thursday, I should be getting those in there. Now, as far as the number systems, let's talk about them now. We're going to be dealing here in computers with 3 different numbering systems, and particularly here in networking, you definitely use them. And you use them in other stuff too. If you do some programming, you're going to use other number systems for some things. If you do photo editing, you actually use other number systems. as part of it. So if you do write web pages, you'll bump into them. So you'll see a lot of this popping up and around. So they get used all over the place because we'll talk about where the usage of each one of them falls. Decimal is the number system that you're used to, and that's what I'd say almost every humans use today that's gotten standardized throughout the world as the one that we're using as humans, is using the decimal number system, which is the one you learned from the time you start growing up. It's not the only one that humans have always used. Humans have used some other number systems. This happened that there's been different groups in the world that have used other systems along the way. The base 60 number system, for a couple of reasons, was actually popular in two parts of the world, but one location impacts us still today, of one group of humans using the base 60 number system. The Babylonians, back in the early times, used a base 60 number system, which meant they had 60 single-digit numbers in the system. We're using decimal, which means it has 10 single-digit numbers in it, which are 0 through 9. The Babylonians came up with base 60 and used it. And actually, I think it was the Mayans, either the Mayans or the Aztecs, and I'm pretty sure it was the Mayans, over here in the Americas, also used a base 60 number system, although the two of them used it differently in how they came up with it. But basically, they came off with in both of them, and this took me a long time to find this out. I read a book on the history of numbers a while back, and it was a book about that thick. Told you everything in the world you might ever want to know about how we came up with numbers and everything else. For a long time, 0 didn't exist. But with the base 60 number systems, they were counting. We're doing with decimal most time. We've come up with decimal because we've got 10 fingers. That's really the reason. Pretty main reason we use a decimal number systems. We're used to 10 to be counting up to. So 10 single-digit numbers. With them, they had counted on all the joints, and I mean all the joints. They had counted off your joints on your fingers, each one of those, then joints up the arm as part of counting, into the shoulder. Apparently counted joints in their legs and everything else, and somehow they found 60 joints. I'm not exactly sure on that one, but that's what they did. And so they came up with a base 60 number system because they were counting using that approach. Somebody dropped out. No, I guess not. Okay. All right. There's 3 of you plus me is 4. Okay. So they came up with a base 60 number system, and that's how they did their counting back there in those ancient times. Somewhere, I think they came along somewhere in the 1000 BCE period, or BC, whichever you want to use on those letters. Used to be BC, now it's BCE. Before Common Era, now BC was before Christ, and then they do CE now for the years after that, year 0, which used to be AD for something in the year of our Lord, or something in Latin is where it came from. And then they changed a while back and went, we should use these different letters. So in any event, somewhere people that lived thousands and thousands years ago, okay, in Babylonia. But off of them coming up with that, and the Babylonians were very advanced people. They, based on the shadows in the whales, figured out what the circumference of the world was, and they had it really, really close. They developed geometry. And remember, I just said about using angles of the sun reflecting in the well. They figured out stuff. They did a lot of other mathematical type things they came up with. And some of them you have to live with today. Think about a clock. How many minutes are in an hour? That's a question. 60. Okay, how many seconds in a minute? Very good. So 60. Now, when you learned how to tell time, was along the same time period you were learning how to count. And I don't know about y'all, but for me it was confusing trying to learn time because everything else I was learning, you counted from 1 to 99 and then you went over to another digit, or things changed and you went to the hundreds. On the clock, you went to 59 and the 60 started over at 0. And that was totally different. And I remember that being confusing to me trying to figure that one out. So there was that. Circle has how many degrees in it? Anybody remember? 360. Okay? Because if something's a sharp right turn, it's that sharp angle right there, that's a 90-degree angle. Notice all those numbers we have just been identifying are groups of 60. Okay, and to me that was another confusing one, was degrees in a circle type thing. Why 360? Where did they get the number 360? Why did somebody come up with that number out of the blue? Well, what it was the Babylonians developed that they came up with how many minutes are in an hour, how many hours are in a day. 24, again, an odd little number, but that's again actually works in a number of 6s to the 60. Okay, so they came up with all of that because they were working on a base 60 number system, not a base 10. And so when we think about time on a clock, that's why that's like it is. It was developed by people using a base 60 number system. Most of the rest of us developed that it developed in a lot of cases, and then finally got pretty well all agreed on, was that we're using base 10 number systems because we've got 10 fingers. And if you were counting something, and some of you may still do this, and when we were little kids we definitely did it, that you may count stuff with your fingers, and when you get to the 10th finger and you still got more to count, it may have been back then that they made a scratch on the ground. We may make a mark on a piece of paper and then count some more with our fingers. Or you may take off your shoe and wiggle a toe, start wiggling a toe to know that one tells you you've used that many. So then when we went to doing numbers, it made sense to do the same approach, and so we used a base 10 number system. There's an infinite number of number systems out there. Now, I want to talk about the base 10 one for a minute, because if you remember these things I'm going to tell you about right here, it's going to make it easy for you to learn the other two number systems. And if you ever encounter some other number systems, and I'm going to mention one other to you. With the base 10 number system, and this is stuff that you learned back in kindergarten, first grade. So that may be ancient history for you, just as well as where I was talking about the Babylonians thousands of years ago. But in decimal, you have the ones column, the tens column, then the hundreds column, then the thousands, and the 10,000s, right? So the ones column, if we look at those and look at what number system this is, we can figure out how it comes up with those numbers for the values on those columns. So the ones column is actually 10 raised to the power of 0. 10 is our number system, and then the first column is always raised to the power of 0. Now, any number raised to the power of 0 is always 1. Remember that. All right, the next column is 10 raised to the power of 1. Any number raised to the power of 1 is itself. So that's the tens column. Well, that you already know. The following one is 10 raised to the power of 2, or you'll talk about a lot of times as 10 squared. And that says 10 times 10, and that gives us 100, and that's the 100s column. The following one is 10 raised to the power of 3, which is 10 times 10 times 10, which is 1,000. Y'all follow where those column values come from now? That we've got those columns right there. Now, what I want you to do is we're going to talk next about binary for a moment. And I could go with either one of them, but we'll go with binary. Binary is actually what the computer is going to work in. So it's using binary. We said humans are using decimal because we got 10 fingers, basically. Okay? But the computer is actually going to work in binary. Everything's stored in binary inside the machine. Well, the reason it uses binary is because it's an electronic machine, and it's easy to represent stuff in binary in the machine. Everything's either a 1 or a 0. It's on or it's off because it's electrical, remember. And we can show it as on or off real easy. But if we have to do it as a partial electricity, that gets tricky. And so that's not going to work real well. So machines have always been binary, because think about a light switch. That normal light switch is either the lights are on or the lights are off. You can get variable switches to set the light on part way, but if one of you goes and if I tell you one of you to go turn the light on 30%, can you get the light turned on exactly 30%? Not really. Okay, so you can take a guess at it, but what Skylar comes up with on the adjustment and what Heather comes up with may well be different on it. Okay, and it's not exact out there. We need it exact stored in the computer, and so that's where binary really comes in nicely to play. Everything it's either there or it's not there. Think about on a DVD or a CD. It works the same way. There's either a hole burned in the CD, which is a pit, or there's not where we're putting information. So if we want to store a 0 on it, we don't burn a hole. If we want to store a 1, we burn a hole, or it may be the other way around. I'm not exactly sure which way it does it on it. But it follows on a system just like that in any event. And so it's easy for the machine to read that CD. Is there a hole? If there's a hole burnt there, it's a 1. Not a hole burnt there, that's a 0. So we can show everything in binary real simply. Actually, with where hopefully we'll get to in here, but I don't know if we will today. With that, if you were having a IoT lighting system that has a dimmer on it, actually what you do is you'd end up storing the values out there in binary out there, and you would have an arbitrary exact amount on it, and so it would know exactly how much, and so that would coming out with the same amount of what, if we were wanting the power at 30%, it would give it exactly the same every time, because it would have a flat, arbitrary, sharp amount that it sets it to, versus us, that it's not a dimmer switch, but it's an arbitrary, specific amount of the power going through to the light on it. So if you told on your IoT light system you wanted the lighting at 30%, every time the lights came on at 30%, you'd get exactly the same thing, and the lighting would be exactly the same each time. As opposed to having us doing it as humans of a twist one, or like where at church, when I control the lights in the sanctuary, it's a slider switch, and I'm putting it at about 80% usually, or cutting it down to 20%. Well, what I do yesterday and what I did it the previous Sunday, maybe some different on it. It'd be pretty close, but it's going to not be exactly the same amount of light. All right, now with the binary there, So everything's stored out there as that. So everything's stored as a binary number. Now, in binary, there's only two numbers, if you haven't guessed that one by now. There's only ones and zeros. And so that's easy for us to store that inside the computer. So we use the binary number system to store stuff inside the computer. Now, in binary, that its column values are not the same as they were in decimal, but they're similar. Remember what I just told you about how you come up with the column values. In decimal, we said we take the base number and then apply it to the power of 0, 1, 2, 3, and so on up. And remember, we can go infinitely off numbers. So in binary, you do the same way, except you use 2. So the first column is 2 raised to the power of 0, which means it's a ones column. Well, that's the same as it was in decimal. The second column is 2 raised to the power of 1, which makes it a twos column. Third column is 2 raised to the power of 2. Well, 2 squared, y'all know that one. That's 4. And then the next one's 2 raised to the power of 3. That's 2 times 2 times 2, which is 8. And if you go on to the next one, it would be 2 raised to the power of 4, which would be 2 times 2 times 2 times 2, which is 16. And actually, effectively, they keep doubling because it's a base 2 number system, so the values keep doubling on up. For purposes of this class, pretty much the biggest one you got to worry about is going 2 to the raised to the power of 7, which is 128, because that actually takes care of a byte worth of information, B-Y-T-E. Now, so that gives us the 1s, 2s, 4s, 8s, okay? Now, hexadecimal is a base 16 number system. Okay, 16 single digit numbers. Hexadecimal is used not inside the computers, and it's not what we're working in, but it's an easy way for us to see what's actually stored inside the computer. Now, the computer is going to be able to convert what's stored in it. The processor will switch it from what's stored in it to where it displays out in decimal numbers, or how it's encoded, it'll display it out into characters we represent that we're used to, like A's, B's, C's, and D's. But you want to be able to see what's actually stored in there sometimes, either on the disk or sitting in memory, because if your programs crash, that can be very useful information to find out what was in there at that point to find, so you can figure out what went wrong. Also, from the viewpoint of security class, since a lot of y'all are doing security also, it's a really good way for you to be able to see when something's happened inside the machine, to be able to look at what's in there, okay? The other place we're going to use hexadecimal is your MAC addresses and your IP version 6 addresses are all expressed in hexadecimal. Okay, your IP version 4 ones are actually expressed in decimal digits, but it's a byte full at a time, so there's where your limitations come in. Okay, if you were to look at a printout showing a dump of a disk or a section of a disk or a dump of the memory, and you started looking through it and you got told, and you got this huge printout of what was in there, printed out just like it's stored in there, which is in binary, you'd have a page full or pages full of zeros and ones. And you got to find on the 18th line, the 25th column, what number is sitting there. Can you imagine that we're doing IP version 6 in this class also. Trying to look at that piece of paper and look down and find the 18th row, keep your hand on it and find the 23rd column. And then tell me, is there a 0 or a 1 there? As you start looking through all of that and looking at all different places in it, your eyes are going to go crazy. Those of you that are on Facebook, you've had friends forward you these charts that are all zeros and there's supposed to be an 8 in the middle of it. or they're all 2s and there's a 7 somewhere in there, and for you to try to find it. It's the same thing looking at a dump coming out of the computer that's just 1s and 0s. It will drive you crazy. Okay? So, hexadecimal exists as a way that we can actually take 4 binary digits and express them as a single hexadecimal character. Now, that works nicely. 2 groups of 4 is how much space? That's 8 bits. How many bits are in a byte? I see somebody typing, I'm assuming no. 8. There's 8 bits in a byte. Okay? So there's 8 single digit numbers could make up a byte. Okay? Binary numbers. Well, if we can express 4 binary digits in a single hexadecimal number, that means each byte's represented in 2 hexadecimal characters. So that works real convenient for us then. Trying to look at them, if we convert them to decimal, it gets really confusing because that doesn't come across that smoothly. But hex works nicely and smoothly on that. So you'll see dumps of stuff shown to you in hex, and you'll also see MAC addresses and IP version 6 addresses expressed to you in hex also. Okay? Now, in both those cases and your IP version 4 ones, which you normally see as decimal numbers, they're all stored in binary on the computer, actually. Okay? But that's also going to answer to you why IP version 4 addresses have some strange rules on them. So with hex, it's base 16. Now, we only know not 10 single-digit numbers, 0 through 9. So what are we going to do? Well, what the standard rule has been is if you have a number system with more than 10 single-digit numbers in it, we go to letters, and that we use letters out of the alphabet. Generally, we're going to see them expressed in uppercase letters, but that's not, you're not going to have a problem with that either way on it. And then they go to, just for your information, if they got bigger than a base 36, then they'd go to Greek characters, and don't ask me what those are. I know alpha is the first one, and beta is the second, but don't ask me any more about them. And zeta is the last one, but I don't know how many there are or whatever. Big one on this one is, just to be aware, we go to letters of the alphabet as numbers. So since we need 6 more numbers, we'll use the letters A through F. So now letters can be numbers. So first part of the lecture I told you, remember what you learned back in first grade or kindergarten. This part I'm telling you, forget what your teacher told you back there in kindergarten, first grade, when they said numbers are numbers and letters are letters and twain shall never cross, or something like that. Now I'm telling you letters can be numbers because IP version 6 is using hexadecimal. So it's using A through F as their other letters. And depending on what type of math you took and stuff, you could have been introduced about some other number systems at some point. But a lot of times, if people did have that, they went over their head. So in hex, you've got 0 through 9 and then A through F. Okay? So now let's look at the column values. The first column be 16 to the power of 0. And any number raised to the power of 0, I told you, is always 1. So that's the ones column. The second column is 16 raised to the power of 1, which is the 16s column. The third column is 16 raised to the power of 2, which happens to be the 256s column. The fourth column is 16 raised to the power of 3, which is the 4096's column, and the fifth column, and you really aren't going to normally have to deal with more than the first two columns. And the next one would be the 64,000 something, and I don't remember exactly the number. Okay, so they grow rapidly. Okay, and that those letters will come into play on it. Now, my handout that I've got out there in the module, definitely pull it and read it. It goes through and will show you how you can convert numbers from decimal to binary and binary to decimal. Okay, and I don't have one written up for going to the hexadecimal and back and forth, but that's that part on. But I do have that one out there, and actually tells you some of the stuff I've just talked you through right now. Okay, and it's a PDF file. It's several chapters long, sitting out there. I actually sell it on Nook. I think for 99 cents or $2.99, and exactly the same little booklet as what's there free for y'all, and I actually have it on my website sitting there for free. And I actually do sell it out there at the Nook. That I get people buying it ever so often. When I ever get a chance, I would like to add another chapter on it of converting, two chapters, one to convert from decimal to hex and one to do binary to hex. Now, what I'm going to try to do is I want to see if I can go to the white panel. Yeah, to the whiteboard. I'll try this and see if I can draw on here and show you some stuff now. So we're going to see how this goes. Was there a comment before I exit out of that? I'm not sure how well. All right. So I do have them out there as freebies, and also that y'all can get it for free. So let me go to the whiteboard. And oh, I gotta get a pencil. So now, yeah, I can write on there. Okay. Whoa. Let's see something. Really haven't used this one, so I want to see. If I hit erase, oh, that's a clear. That clears everything if I hit that eraser. I have to remember that on there. So I'm going to go with this drawing, and now I'm going to try to do this for y'all. Okay, so if we got the number 1010, that's a 0, believe it or not, and it is a base 2 number system. And you normally, if it's not base 10, you're going to put it as a subscript afterwards. Okay, and then we don't normally, when we're converting from one number system to the other, you'll see people use equal signs there, but technically it should be that equivalent sign, which is that tilde type thing on it. It's on your keyboard. Most keyboards, it's sitting up there at the top left, right below the escape key. Now, what we want to do is convert that number to decimal. So if we want to convert to decimal, what we're going to do from binary is we're going to number our columns here, find out what each of the values of the columns are. So I'm going to write them underneath. So get back to my pencil. So I'm going to have the ones column, the twos column, the fours column. This is not the easiest thing to do. And the eights column. So that's a 2, believe it or not. Okay, that might make it a little better. So now what I'm going to do is I'm going to take all of the columns that have ones in them and add them up. So there's a 1 in this column, which is the twos column, so I'm going to do it 2. And then there's a 1 in the eights column, so I'm going to put the 8. I'm going to add those up, and that gives me 10. That's my decimal equivalent of 1010 in binary. Let me click back on chat so I can see what y'all say, if anybody says anything. Y'all catch that one there on that? Now, I wish, I don't want to clear the whole screen. I just want to erase part of the screen. I'm trying to find if there's an eraser here, because what they show as an eraser clears everything. Any questions on that before I erase that one? All right, I'm going to go ahead and wipe that out. I'm going to go the other direction next. So now you're 16 years old. Oh, I got to go back to the pencil again. That's interesting. It straightened up the line slightly for me. And I want to convert that from there to a base 2 number. Okay? I'm going to take that 16 and I'm going to come up with my columns over here that I'm going to have until I get a column bigger than this number. I don't really like that number. Well, let's go ahead and go with it anyway. So I'm going to have the 1s column, the 2s column, the 4s column, the 8s column, the 16s column, and the 32s column, because that's bigger than that number. Then now, how many times will 16 go into 16? 1 time. So then I'm going to subtract 16 from the 16, and that leaves 0. Now, will 8 go into 0? Nope. So I'll put a 0 in the 8s column. 4 go into 0? No. So I'll put a 0. Will 2 go into 0? No. So I'll put a 0. Will 1 go into 0? Nope. So I'll put a 1. And so 16 as a decimal number converts to 10000 as a binary number. So if you happen to be 16 years old, you might want to tell the bartender that your age and binary instead and see if he'll fall for it and sell you a drink. Or be able to go vote in the election because now you're more than 18 years old. Does everybody follow how that one works? Let's try another one, because that one you just had to do 1 column. So I'm going to do a different number. So I'm going to pick 13. Whoops. And we're going to convert it. And we're trying to get to a binary number again. So we're going to come up with a 1s column, our 2s column, our 4s, our 8s, our 16s, and that's as far as we're going to go. 16 is bigger than that, so that's the reason we want to go to there. Now, if you get, and while you're doing this, if you end up with anything other than a 1 or a 0, you've made a mistake in the columns. So 8 will go into 13 1 time, right? So we'll put a 1 in the 8s. We'll subtract 8 from this. That leaves 5. 4 will go into 5 1 time, right? So we'll put a 1. We'll subtract 4 from that. That leaves 1. 2 won't go into 1, so we'll put a 0 there. And then 1 will go into 1, so we'll put a 1 there, subtract the 1 from there, and we've got nothing left, so that worked out right. Does everybody follow how that one works? So that works real nicely on doing those conversions. Okay, so that was binary to decimal and decimal to binary. Okay, now I suspect the book goes a different way. I don't really understand that way, but sometimes some students do, doing all kinds of divisions, but I like my way. But like I say, you can use either way, whatever makes sense to you. If you really like this, like you are saying right here, you might want to just sort of skip easy on the book. If you look at the book and go, I'm confused, don't worry about it. You know a way to do it. That's all that's important for you to do. Okay? Now, let's go from binary to hexadecimal. So I'm going to, again, come up with a binary number. This time I'm going to get one that is 8 digits long. Well, I didn't mean to write 8 right there. So I'm going to go to a white color so I can. I don't like where they don't have an eraser, they just have a clear button. That's not good. So come back to my pencil, I'll put another 0 and put a 1. So that's a binary number. We're going to go to base 16 this time. Okay. Now, remember what I told you about that 4 binary numbers will fit into 1 hexadecimal number. Let me finish this one, Heather, and I'll come back and do one more for you. Okay. If we want to take a binary number to a hexadecimal number, we can group it in groups of 4. 2, 3, 4. And then each of these groups will convert into a single hexadecimal number. So this first one, and so we're then going to number it like we did just before, except with one difference. When we were doing the binary to decimal, we kept on numbering. So we would have gone 1, 2, 4, 8, 16, 32. And here, these are groups of 4, and this is just for this conversion part. We're just going to number each group. There's that one. Then I'm going to start all over again for this next group. Now, this first one, we're going to take all the columns that got 1s in, I'm going to add them up. So we've got 8 plus 4 plus 1. That gives us 13. That's going to be our first single-digit number over here. But 13 is not a single-digit number, right? So 9 is our biggest single-digit number. 10 will be the next one, which would be the letter A. 11 would be B. 12 would be C. 13 would be D. So that means our number here is a letter D. That's not a 0. That is actually a D. I think I'm going to put it in lowercase just to make it clearer. Okay? Now, this one, we've only got a 1 in the 2's position. Well, 2, that works. That's a single-digit number. So our answer is 2D. Y'all follow that one? So you're going to break it in groups of 4 and convert each of them over to a number. Any questions on that one? Yeah, I know it mixes it up. It's a little bit different system, but it makes it simple, and it's still actually, the biggest difference is you're splitting in groups of 4, and that you're only working with a group of 4 at a time, and it goes to a single character. But it makes more sense to me on this one. Now, others will come up with something different for you. Okay? Now, here's another one I'll tell you on though. You can also, once we get these figured out, if you've got a binary number and you need to get it to hexadecimal, and you can remember how to get binary to decimal and decimal to hex, you can actually do that. Even though you didn't remember how to do binary to hex. So you got little sneaky ways to get around it. All right, I'm going to clear that one. So to go from binary to hex, we do it that way. I'm going to clear it, and we're going to go the other direction, hex to binary. So we'll take a hex number, and just to make it clear that it's a hex, we'll use a letter in here. So I'm going to do 4A. That's equivalent to, and we're going to base 10. So this is base 16, so it really needs a number up. Now, for that one, we're actually going to work the reverse of what we just did. So the A, since we're trying to go to binary, we're going to think about what is that one. It's an A. Well, that's not a number like we're used to, so we know it goes one beyond. We know A is equivalent of 10. So then we're going to put 10 into binary here. So we're going to have the 1s, the 2s, the 4s, the 8s, and we're going to come up with a single digit binary number. So 10 will convert into binary as that 8 goes into it one time, 4 does not go into the remaining because 8 from 10 is 2. So we'll put a 0 in the 4s. 2 will go into 2 one time, so we'll put 1. Subtract 2 from the 2, that leaves 0, so that means 0 goes there. All right, now the next one is we got 4 to convert, so we're going to do the same again. 1, 2, 4, 8. Now 4 won't go into 8, so we'll put a 0. 4 will go into 4, so we'll put a 1. 4 from 4 is 0, so we'll put a 0 in the 2s and a 0 in the 1s. So there's our answer. And we really don't have to worry about this one on it, of the leading 0, because leading 0 in whatever numbering system is the same, except for if it's a leading 0 right here, that 0 has to stay. But if it's your overall number, you can drop the leading 0. But you can also treat it as is, because somebody could say they are 035 years old, 05 years old, or they could say they're 35 years old, and all three things are saying the same time. So in this case, it's that 01001010 or 1001010, and binary is equivalent to 4A in base 16. You see where it gets a whole lot smaller in hexadecimal. All right, now let's go from hex to decimal. And this is where you may get a little bit more confusing. So we're going to do 3A. No, I'm going to do a 3F and hex. And we're going to go to decimal. In this case, what we're going to do is we're going to number our values over here. So that's the 1s, the 16s column. Well, we got an F in the 1s column. F is actually equivalent to 15 because A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So that's 15 times 1. So we're going to take that number in that column, multiply it by the value of the column, get an answer, which is 15. The next one is 3 in the 16s column. So that's 3. It just tried to clean up my work for me and goofed it up. 3 times 16, which gives us 48. We add those together and we get 63. And 63 is our answer. Now, your biggest ones you're going to do is going to be more decimal to binary. But doing hex to decimal, you're not going to do very often. But let's do the decimal to hex just so you see that one too. Decimal to hex, we'll take a hex number. We just used 35 a moment ago as a number we threw out, so we said she was 35 years old. So let's find out what she is in hex. How old she is in hex now. Okay, she's 35 in decimal. Now, in this case, we're going to number our columns again, the 1s, the 16s, and then it's the 256s. So you usually do put them sideways to make them line up to one column. 256 is bigger than it. 16 is not, so we'll see how many times will 16 go into 35? 2 times. So we'll put a 2 over here. 2 times 16 is 32. We'll subtract that from there. That leaves 3. Notice this resembles how we did the binary conversion to the decimal on it earlier. And we've got 3 left, so we'll take the 3 and put it in the 1s column because we're down to the 1s column. So 35 in decimal, or she's 16 in hexadecimal. So people that want to be younger might want to express it in hexadecimal instead. If you want to weigh less, you want to express it in hexadecimal. Probably don't want to express your weight in hexadecimal, or in binary, I mean, because you're going to weigh a whole lot more. So have fun with that one. All right, so we've done those. Now, this bit of decimal to hex and vice versa, you're not going to see that very often, but be aware. Just be aware on that. But I want you to see how they're all working. So I'm going to go back. Heather, do you want me to do binary to decimal or decimal to binary? Okay. But y'all get the idea on it, and I did record this session, so y'all can actually go back and watch it again. Because this one really, and then the other part, like I say, is watch my videos that I've got out there, because I actually go through all of this where I was teaching in class. They're about 15 years old, probably. They're from the early 2000s. Filmed good on them. The assistant librarian and I did the filming on it, and that he actually stood there and filmed me on part of it, or he'd set up the camera back in the classroom. Versus the videos I'm doing now of me teaching in the classroom, I'm using the webcam I've got right here. I'm having to use it on the instructor's machine at the front of the room, and that's a little hard to try to get it set up where it's catching the front of me, I noticed. So you see a lot of the back of me on it where I'm trying to catch some of the board too. I don't have a username and password to be able to use the student machines to work from there. But that's where I need to set it up on, is connected on those. But I'll also have video put out there of me teaching it in class tomorrow in the 2 classes and Thursday. So you'll have those. So you've got some reviews on this and to learn about it. Hopefully that all helped you and makes a whole lot more sense. We have used up our 55 minutes I set out there for us for today. I've got another of these in 2 minutes for another session, and I'm not even sure which class I'm going into now. 12, 20, 61, 51. Oh, it's my programming class, my PHP class. So I've got to go hit that one now. So I'm going to shut this one off. So hopefully from here on through the rest of the semester will be on Mondays at this time. We could have something pop up and change it slightly, but the intention is to stay on this time. So I will see y'all next week. If you have questions, write me. The other part is, if y'all go, can we just do a session, have him do a session just on doing some more of this? Yeah, we can set that up and just set a collaborate session up at any time, and that we can squeeze one in at some other point too. So yes, we can do something else if we need.